Hey, welcome back. Today we're looking at graphing transformations. Um, the general rules, so if we're talking about family of functions, if we have any particular function f, right, we're going to be able to tell what's happening with the graph of f if we know what the base function is, what the graph of the base function is, and if we know all these different parts of it. So inside of our function, x minus h, that moves it left and right. Now the key to this though is that because it's x minus h, if we were having a positive h, it would look like x minus, like say we had 3, that'd be a translation to the right 3. But if we had a negative 2, for example, for h, if we want to move it to the left, it'd be x minus negative 2, and therefore it looked like x plus. So with the inside, right, inside the parentheses, what we want to probably note is some of us might know this already, but some of us might have forgot it, that we could do the math for it and talk about it that way, but probably the easier way to do it is that it's just the opposite, right? So it's the opposite for the inside for our translation. So if it's a minus, we go to the right. If it's a plus, we go to the left. It's just one of those weird things inside of the parentheses for the transformation stuff. Okay, the k outside, that just shifts it up and down. So this shifts it up and down. This one is straightforward. It's not opposite. It's just positive up, negative down. We don't talk about this one much in math, but negative x, what that does is flips it over the y-axis. You might come across it in rare occasions, but yeah, it's not too common. If our a determines kind of a lot of things. So if it's a negative, then it flips it over the x-axis. If a is greater than 1, it's going to be a vertical stretch. So like, let's say we have a parabola. This is x squared. If we did 4x squared, what that would make it look like is it stretch it upwards and make it look a lot skinnier. Okay, and then likewise, if a is less than 1 but greater than 0, it's going to be a compression. So it's going to look like it's going to be the same vertex, but it's going to be pushed down that way. Okay, so stuff that you probably covered in Algebra 2, maybe even in Algebra 1, but we're just going to kind of reinforce it in this lesson. Okay, so let's write an equation here. So let's note what's going on here. So first of all, if I look at this, I know this is a parabola, but what I know about the parabola is that the base parabola y equals x squared starts at the origin. So there's a couple things going on here. So one of it is that it's pushed up 3 units. Right, so that's the first thing. It went up 3 units for our vertex. And then it got flipped over. So then flipped on the x-axis. Okay, so we're going to start with this base function and we're going to apply these two ideas. So if I know that it's up 3 units, then I'm going to say y equals x squared plus 3. So that checks that first thing off, right? We said that outside of our function is x squared. If we're adding or subtracting, plus goes up, minus goes down. So we just shifted up 3 units. The second one, it flipped with the x-axis. So if we go back here and check, okay, so if I flip over the x-axis, I just need to make my negative in front of the function. So my function is x squared. I just have to make it a negative. Okay, so I know that these two things that we did to transform our graph and our equation reflect the graph that we're looking at in front of us. Okay, part 2. So for us, we kind of didn't mention this earlier, even though I have it written down. So for x squared, the base function is just x squared. It's a parabola. It's opening upward, and the origin is at 0, 0, or the vertex is at 0, 0. The absolute value function is pretty much similar, except for it's a V-shaped graph, and the vertex is again at 0, 0. So if we're looking at this next one, this is definitely an absolute value of x, right? But what we know about the absolute value of x1 is that we have it based at the origin. The vertex is at the origin. And the slope, if we look at here, is going to be 1. All right, so there's a few things that happened here. It shifted down, right, to get from this point to this point. It went down 2. It went right 3. And it got skinnier. So let's just say that the the stretch is a 2. So instead of the slope being 1, this time the slope is going to be 2. Okay? So in order for us to write this, let's kind of start with our function, y equals the absolute value of x. All right, so, well, let's start with the inside first. It's probably easier. So because we went right 3, right, we said that it's opposite sign, so it's going to be -3 inside, right? So this is the inside. Left and right is inside of the function. So our function is absolute value. We're writing that -3 inside the absolute value. Okay, it went down 2, so we know that's outside, right? Outside. And then it's going to be down, so -2. And then the stretch 2, that's our a. So our a comes in front of our function. We'll just put a 2 in front of our function. Okay, and then that is pretty much it. All right, so let's kind of do that same idea here. This time they're giving us our base function y equals absolute value of x. So if we want to shift right 1, right and left is inside, right? So y equals, and remember inside the parentheses, it's actually opposite, right? So if we want to go to the right, it's minus. Okay, that's pretty easy. Down 3 is outside. -3. Reflect x-axis. That's just going to be negative. So y equals negative outside absolute value of x. And then vertical stretch 2, just like we did the last time, is our a. Okay, so pretty simple. Once you get the hang of it and once you understand, then all the other stuff that you guys are going to do dealing with family of functions and vertex form and stuff like that is going to be a little bit easier. Okay, so that's it for today. Make sure that you have your notes taken. If you have any questions, again, please come to class so I can help